Hello and welcome to day 8, surface area of cones and pyramids. And so when we talk about the surface area of a cone, this is the formula that we're going to use. It's very similar to the cylinder, but you'll notice that the area of the base, there's only one of them, so there's only one circle on the bottom. And then this is the formula that we use to find the area of the surface area of the cone part. And this cursive L comes from, it's the slant height of the cone. And sometimes that you'll ask you to find that slant height in order to do this. Oops, and if I could draw a straight line for the radius, that's supposed to be a radius. The radius and the height will meet at a 90-degree angle, so sometimes you'll have to use Pythagorean theorem to find the slant height given the radius and the height of the cone. So just be careful of that. And then down here, we are talking about finding the surface area of a pyramid, and so the area of the base will depend on what the shape of the base is. If the base is a triangle, you'll have to use the triangle formula. If you're using a square or a rectangle, you'd use the square or rectangle formula. It could be a hexagon or an octagon, and so you'll have to use the regular polygon. And then over here, you are basically finding the area of the triangles that make up the sides. And so that's where this comes from, is that L is the slant height, and if I was to draw it in, I'll draw it in over on the side over here. It is the slant height of the shape. It's really the height of the triangles. You know, here's another one, goes up the front here, and so that's the slant height. It's the height of each triangle, so that height times the base cut in half would be the area of the triangle, and so this is the formula that we use to find the pyramid, the surface area of a pyramid. And so make sure you get this down. This is perimeter of the base right there, perimeter of the base. This is area of the base depending on what the base shape is. So here are two examples of how we might do that. And so if we're going to find the surface area of this cone, we have to remember our surface area formula, and that is pi r squared, the area of the base, plus pi r L, and the L is the slant height. Well, if I label what's on here, I know that my slant height is 40 millimeters, and I know the radius here is 15 millimeters, and so I can go ahead and plug in what I know. Well, for surface area, it's going to be pi times 15 squared plus pi times 15 times 40. So in terms of pi, I'm going to end up with some number. Let's see what do we get here. We're going to end up with 825 pi millimeters squared. That would be our surface area, and I just basically crunched these numbers. 15 squared is 225. 15 times 40 is going to be I think 600, and so we end up with 600 plus 225 pi, which gave me the 825 pi. And then if I want to find out a little bit more accurate, I'm going to take that 825 and multiply it by 3.14, and that gives me a surface area of 2,590.5 millimeters squared. And so that would be the surface area of the cone. Well, how does it work for a pyramid? Well, the pyramid's base is a square, 100 feet by 100 feet, and the slant height is 80. So the slant height on the, let's see, these guys are 100 down here. Let's see if I can write in a color that you might be able to see. There's 100 on each side of the square base, and we have a slant height, which I'll just draw on this one right here, of 80 feet. So if I go with my formula, well, if all else fails, let's find the area of the base. Let's find the area of the base, and for this one, I don't know if we actually need the surface area of the base, because if we were going to cover it, do we really need to know it? Probably not. But we'll find it anyway, just as a practice. So the area of the base is going to be 100 times 100, which gives me, I think, let's see, it gives me 10,000, of course, a 1 with 4 zeros after it. And so there's 10,000 square feet for the base, and there's an argument whether or not we need it for this, because maybe I want to cover this with wallpaper, and I wouldn't cover the base with wallpaper. If I was going to wrap it up as a present and give it to somebody, then yeah, I probably would want the area of the base. So then, to find the area of all the triangles, we could do an area of a triangle, which would be 80 times 100. The base times the height and divide it by 2, and that would be the area of one triangle, which I believe would get me 4,000 square feet. And so that's one of them, but there are 4 of them, so I'd have to multiply that by 4, so the area of 4 triangles would be 4 times the 4,000, which I believe will get me 16,000 square feet. Alright, so that would be the area of all four triangles, and then if I was going to wrap this up and give it as a present, then I would add the 10,000 to it to get the total surface area, or if this was a pyramid that I could pick up, then the total surface area of this thing is 26,000 square feet. So this is just using the formulas. I didn't really use a formula for this one, but remember that I could have. The surface area is found by the area of the base, which is what I did first, plus 1/2 the perimeter of the base times the slant height. Well, let's just quickly discuss the perimeter of the base times the slant height in this one. We'll talk about this, how I got the 16,000 without doing that, and you don't have to do this if you don't remember it. But if I take 1/2, the perimeter of the base is 100 on each side, so there's 4 100s, so 400, and then the slant height is 80, and so if I multiply that out, and then cut it in half, I will end up with the 16,000 square feet that I got before. So it's just a matter of, you could either use this formula to get that, or you could logically think your way through it, whatever helps you the best to get through this problem. So if you have any questions, please come to class prepared to ask them.